Here is an example of a scatter plot with a linear model. The scatter plot shows the sale price of several food items, X, and the cost of the ingredients used to produce those items, Y, as well as a line that models the data. The equation of the line is Y equals 3.48X plus 0.76. What is the predicted sale price of an item that has ingredients that cost $1.50? Look at the line modeling the data through the scatter plot. If you draw a line up from the x-axis at 1.5 to the model line, the y-coordinate is about 6. This means the predicted sale price is $6. What is the predicted ingredient cost of an item that has a sale price of $7? Look at the line modeling the data through the scatter plot. If you draw a line from the y-axis at 7 to the model line, the x-coordinate is about $1.75. This means the predicted ingredient cost of an item that has a sale price of $7 is $1.75. What is the slope of the linear model? What does that mean in this situation? Remember that slope is rise over run. Pick 2 points on the graph. It's easiest if you can find 2 points that are 1 apart on the x-axis. If you pick the points where x is 1.5 and 2.5, you can see that the rise is about 3.5 when the run is about 1. So the slope is about 3.5. So what does this mean in the problem? For every $1 increase of ingredient cost, the sale price increases about $3.50. Now, what is the y-intercept of the linear model? What does this mean in this situation? The y-intercept is when x equals 0. That happens when y is about 0.75. Does this make sense in this problem? No, because if the ingredient cost is $0, there should not be any sale price.